Much of our everyday beliefs about how the world works, including virtually all of our scientific reasoning, are based upon induction. Hume shows that all of this so-called knowledge is ultimately without foundation, and so possibly not knowledge at all. This should be somewhat disconcerting, for after all, we would like to think that faith in science and its methods is more than mere superstition, that it's much better warranted than, say, gazing into crystal balls. Hume states, suppose all knowledge and ideas derive from experience. Then there are two kinds of knowledge: matters of fact, which relate ideas from prior experience to new experience, and relations of ideas, which relate ideas from prior experience to each other. The former give us real knowledge, but no certainty or necessity. For example, I can say that the sun is shining while it is raining outside. This cannot be disproved except by looking out the window. It cannot be verified by logic or reason. Relations of ideas are fairly useless also, even though they are logically true. If I know the meaning of the word bachelor and the meaning of the word unmarried, and I say all bachelors are unmarried, this is true. But it tells me little about the world or truth. When this dichotomy is applied to a host of issues, according to philosophers, it eliminates all knowledge of necessity in experience or reality. There is no necessity or power by which cause brings about effect, according to Hume. We cannot rationally show the sun will rise tomorrow, or the dropped ball will fall. Hume states that one cannot predict the future from past experience. The ball falls when I let go of it. To say that it must fall the next time I drop it is not logically possible. If I state that gravity will make the ball fall the next time, Hume counters that I cannot see gravity or any power that makes the ball fall. If I carry this argument of unseen powers creating causality in the world, then I could finally argue that unseen dwarfs or gnomes are causing things to happen. And indeed, a noted theologian, as we shall see in a latter lecture, does assert that physical evil in the world might be caused by unseen evil devils or creatures from other planets. He thus accounts for physical evil in order to disassociate God from it. For Hume, scientific statements merely summarize past experience. They cannot predict the future. He also believes that there can be no rational arguments for the existence of substance, either material or mental or God. Hume's skeptical solution. We can't really help but reason inductively. A being that was purely rational would never form any beliefs based upon induction, and so would never draw any generalizations or make any predictions about the future. But of course, such a being couldn't possibly make its way around in the world. Try driving a car without making any inductive predictions. How would you point the steering wheel? So nature, through the operation of custom and habit, has determined that we draw inductive inferences. Thus, while we really cannot know the true causal powers of things or the course of the future, we can know the customs or habits that our mind has formed through its experiences. At this point, Hume adopts a skeptical solution to the problem. The strategy here is to translate statements about matters the skeptic claims we can't have any knowledge about into statements about things our knowledge of which is not thrown into question. So statements about the causal powers of things really should be reconceived as statements about the connections in our minds between the ideas of those things. We are safe, according to Hume, from any disastrous consequences of his thinking. We will jump out of the way of the car, or in his day, the carriage swooping down upon us, without caring about the fact that we cannot logically predict that it might kill us. We are formed by nature, and we are creatures who operate largely by habit and the customs that we are brought up in and which surround us. Hume talks about leaving his philosophical work for a few hours and going out to talk and laugh with friends, to play billiards and then return to his studies. He states that they strike him as so cold and so fantastical that he wants to leave them and not take them up again. We are not at liberty as humans, Hume explains, to cease to believe in received wisdom about the world or the claimed knowledge about the world. He famously concludes that nature is too strong for principle. Our second cautionary thinker concerning scientific knowledge and claims is Thomas Kuhn, whose 1962 structure of scientific revolutions is well worth discussing. There are many scientists and philosophers in the present day who think he went too far, but the fact that he has raised certain questions and that they still must be dealt with over and over makes his ideas important to consider. Kuhn states that what we have traditionally believed about science is that it is an accumulation of facts, and that this accumulation keeps progressing and being built up in an orderly fashion until one has, as it were, a scientific edifice, which keeps being added to by new facts. And of course, this is how normal science proceeds, as it must. Kuhn defines a paradigm in a very contemporary manner. He has adopted the term to describe a set of practices that determine a scientific discipline at any one particular period of time. He explained that it is an universally recognized scientific achievement that for a time provides model problems and solutions. However, in time, cracks begin to appear in an established edifice. New ideas and practices appear. Many scientific revolutions do not succeed. Their ideas and practices are not correct. But when a new paradigm emerges that is seen to provide model problems and solutions and is better than the earlier one, there is a genuine scientific revolution. One paradigm is overthrown by another, such as Copernican science being replaced by Newtonian. It is somewhat as though the exoskeleton of the edifice molts and is replaced by a more useful one. The successive transition from one paradigm to another via revolution is the usual developmental pattern of mature science. But let us look at the downside of each new revolution. Because the new principles and practices harden and do not become tentative or merely considered a useful model for a period of time, but a conceptual vision that does not tolerate departure from its precepts and practices. Students study these paradigms in order to become members of the particular scientific community in which they will later practice, do research, publish papers, receive salaries, and obtain tenure. Kuhn states, because the student largely learns from and is mentored by researchers who learn the basis of their field from the same concrete models, there is seldom disagreement over fundamentals. Men whose research is based on shared paradigms are committed to the same rules and standards for scientific practice. A shared commitment to a paradigm ensures that its practitioners engage in the paradigmatic observations that its own paradigm can do the most to explain, i.e., investigate the kinds of research questions to which their own theories can most easily provide answers. One can see the difficulties inherent in such a hardening of practices, which the French philosopher Foucault called a mindset. He meant this disparagingly. As should be obvious by now, there is a great danger that any terms and meanings used in so-called normal science can only be used in that new paradigm, not for the old and not for the future one. Are scientific observations neutral? Kuhn's work would suggest that they are not. Here are a few inferences to make from Kuhn's research. Paradigms are incommensurable, untranslatable between each other. No logical inferences can be made across paradigms. Although Kuhn's ideas are very disputed today, he has raised the ante for science to account for its own neutrality. Indeed, we can say that he implies that theory change is not just scientifically, but sociologically based. The question of the rationality of paradigms being rationally based is obvious. Each paradigm might contain within it a non-rational core. I, as an atheist, am very science-oriented, but I believe Hume and Kuhn should be kept in mind when we are urged to accept whatever new paradigm arises, particularly as Joseph Margolis, a neo-pragmatist, suggests in the realm of the social and other soft sciences. Margolis and others argue that the hard sciences may be approached with less relativism. To conclude this section, I need to refer to that philosopher that we atheists are very fortunate to have working to explicate difficult ideas and theories, Michael Martin. His discussion of naturalism in the New Encyclopedia of Unbelief is superb and arcane. I will briefly summarize his position, but anyone interested in naturalism, ontological, metaphysical, and methodological should turn to the master himself. I have referenced his article on AtheistScholar.org and also recommended his books. Martin states that three rationales provide a strong case for what he calls ontological naturalism. He characterizes ontological naturalism in terms of what is scientifically explicable. This is problematical, as it does leave some room for a naturalistic idea of a God, nor does it rule out a belief in a God or gods interpreted in a non-supernatural way, although most people think of God as a supernatural being, and most atheists mean they hold a view that rejects God. Martin makes an important point. If God only means what Dewey meant by this term, the famous atheist of history could well believe that God exists. The highest expression of human ideals is what Dewey said. Martin concludes, though, after a closely argued essay, that three rationales provide a strong case for ontological naturalism: the success of science, the case for atheism, and the incoherence of supernaturalism. I believe that Martin is the premier defender of atheism against such supposedly formidable theists as Alvin Plantinga and Richard Swinburne. I strongly recommend his books.